Hi everyone. Here are a couple of examples getting started with function notation. So we just want to make sure we're comfortable with the notation for this section. Okay, so first one, I have a function that's described with words, and we want to make sure that we can make some sense of some statements given in function notation. All right, so our function, b equals n of t. So when I look at this, make sure you're recognizing that t is your input variable. We're inputting t values. B is your output variable. We're outputting b values. And n is the name of the function that pairs b values with t values. So function n pairs b's and t's. And this represents the number of birds in thousands. So B is the number of birds in thousands, migrating through Washington T years after 1990. So both of these variables have a little bit of a particular definition. You want to make sure you're really careful with that. We need to make sure that anytime we see a B value, we recognize that that is thousands of birds, not just birds. And anytime we see a T value, that's the number of years after 1990. All right, so first statement here, we want to explain the meaning of n of 7 equals 9.2 using everyday language. This everyday language thing actually is really important to me. It's great if we can sort out the meaning of that, but part of the job of mathematics is to be able to then take something like that and explain it in a nice, clear way where somebody who is not taking pre-calculus could understand what the statement means. So n of 7 equals 9.2. 7 is our input values, and inputs we've already decided are t's. So this is 7 years after 1990. And the 9.2 is our output value. We've decided that our output variable b is giving us thousands of birds. So this is giving me a basic understanding. 7 years after 1990, there's 9.2 thousand birds migrating through Washington. I think I can do a lot better if I'm trying to make that everyday language. I don't know about you, but I think 7 years after 1990 is sort of an awkward way to say it. And I definitely think 9.2 thousand birds is a strange thing to say. I wouldn't mind 9.2 million or billion, but I don't think it's normal for people to say 9.2 thousand. So if I want to nicely explain this with everyday language, I would simplify it as much as possible and say in 1997, 9,200 birds were migrating through Washington. I do not need you to word this exactly as I word it. This is definitely open for you to give whatever wording you see fit within reason. Again, I am going to look for it to be simplified. So if you do things like 7 years after 1990 or 9.2 thousand, I would say, yes, it's really clear to me what the answer is, but I don't think you quite simplified it. Just so that you get what I'm thinking when I look at that. If you were solving an equation and you stopped at x plus 2 equals 7, it's really clear to me what the answer is, but that doesn't mean you're done solving. You need to take the last step, subtract 2 from both sides, and tell me that x equals 5. So please change your wording from 7 years after 1990 to in 1997, and from 9.2 thousand birds to 9,200 birds. So I really do want you to do your best for everyday language on this. Okay, this one has one more part. If n of 9 is equal to 6.1, find the average rate of change of n from t equals 7 to t equals 9 and explain its meaning using everyday language. Okay, so we are supposed to calculate an average rate of change, which means we need 2 points. One of our points was given in part A. So if I know that n of 7 equals 9.2, that means I have a 0.7, 9.2. And then in this new part, we're given another point, n of 9 equals 6.1. So We have the 0.9, 6.1. If you remember your average rate of change formula, we are supposed to take change in y over change in x, so it's slope, and you get to choose which is your first and which is your second point. So I'm going to say 9.2 minus 6.1 is my change in y. So I've chosen order here. If I'm doing 9.2 minus a 6.1, I just need to make sure that I'm using the correct order for the corresponding input values. So 7 was the input that goes with 9.2, and 9 was the input that goes with 6.1. Okay, so we need 9.2 minus 6.1, 3.1 over negative 2, which is going to give us 1.55, negative 1.55. Okay, so this is my average rate of change. I'm also supposed to explain what that means using everyday language. These can be a little bit awkward to explain, but just remember that it's a slope. So slopes are always fractions, change in y over change in x. And in fact, if you wanted to, you could use this 3.1 over negative 2, but I'll go ahead and stick with my negative 1.55. And remember that this is saying the change in our output variable is negative 1.55, so that's change in b. This delta right here is something that's really common for people in math to use for change. And the 1 is a change in t. So this is for every 1 year, the number of birds migrating through Washington is expected to decrease by 1.55 thousand. So again, making that sound a little bit better, 1,550. It is really good to identify that this is just an average. This is not perfect, but if we average over the 2 years, that's the decrease we're getting, and to specify what years we're talking about. So I would say if we want to get all of the information in this statement, it would be something like this. Between 1997 and 1999, the number of birds migrating through Washington decreased by 1,550 per year on average. I would say that's a really complete interpretation of the average rate of change. So when I'm looking at those, this is a little bit of a picky one. You want to make sure that you have given the interval for which the average rate of change is valid, that you've clearly described the change in your output variable, change in your input variable part, so decreased by 1,550 every 1 year. Those are really important. And you want to make sure that you mention that it is in fact an average. So be really careful about those. That's one of our messier interpretations.